we're going to look at similar areas in this video. Now what I'd like you to do is to consider two rectangles. And let's say this one is 3 by 4 and this one is let's just say 9 by 12. Now the area of this shape is 3 times 4, which is 12 units squared, and the area of this shape is 9 times 12, which is 108 units squared. Next thing to consider is, how do we get from 12 to 108? Well, 108 over 12 is 9. Now, what we could call this the area scale factor, which I'm going to abbreviate to ASF. We could call the area scale factor 9, because the larger shape is 9 times the area of the smaller shape. Now what I'd also like to do is to work out the linear scale factor, which is the scale factor we've been using. We just didn't have the word linear in front of it. So the scale factor. Now, formula is final over initial. So let's take the 12 and the 4 as corresponding sides. 12 over 4 equals 3. So we have a linear scale factor of 3 and an area scale factor of 9. Now I wonder if you can make the connection between the two. How do we get from the number 3 to the number 9? Well, what we want to do is to square. So we square the linear scale factor to get the area scale factor. So what did we say then? So the area scale factor equals the linear scale factor squared. And we could also say that the linear scale factor is the square root of the area scale factor. We will use that in a later example. Example 1, so we know that the two shapes are similar. That's important. Now it says that the perimeter of A is 32. So, well, let's consider shape A. So if that side is 10, this side must also be 10. Now 10 plus 10 is 20, and how do we get from 20 to 32? You have to add on 12, which means that this side must be 6, and this side must be 6 as well. So if we know that's 6, why don't we put an x here and calculate the length of this side? So the scale factor, I'm going to do enlargement because we're starting off with a smaller shape and finishing with a larger shape, so enlargement. Final over initial. I'm going to use the 20 and the 10, simple numbers. That means scale factor is 2. The linear scale factor, let me just put an L in front of this, linear scale factor is 2. So x then is found by multiplying 6 by 2. So x is 12 centimetres, and the perimeter of shape B is going to be 20 plus 20 plus 12 plus 12, and that equals 40, 50, 64 centimetres. Now the part that really interests us is to do with area. So the area scale factor is the linear or length scale factor squared. Now we know that the length scale factor, linear scale factor, is 2, so 2 squared is 4. That means that the area of shape B, so area B equals 4 times area A. Now we know that the area of A is 60. Second example, so these shapes are similar and we have enough information to work out the linear scale factor. So that's 28 over 4, beg your pardon, 28 over 7, which gives us a linear scale factor of 4. So that means that area B is what? So the area scale factor is the linear scale factor squared. So that means that area B is 16 times area A. We know that area B is 320. That equals 16 times A. So if we divide by 16, it gives us the value 20 centimetres squared. Example 3 is slightly different because we're missing a length. So we've got both areas, but we'd have only one of the lengths. So remember, area scale factor is the length scale factor squared, and we also said that the square root of the area scale factor gives us the length scale factor. So what I want to do here is work out the area scale factor enlargement. So 64 over 8 gives us 8. So the area of B is 8 times the area of, well, we call that A and B. So area B is 8 times that of area A. Now, the length scale factor, which is what we wanted, is found by taking the square root of the area scale factor. So it's the square root of 8, which is a slightly awkward number, but we can use it. So that means that to get from the 2 centimetres to this missing value here, we multiply by the square root of 8. So C equals 2 times the square root of 8, which is 5.67